Good morning, dear friends. So today I am going to discuss about the oxidation reaction. So what is meant by oxidation? Just addition of oxygen or removal of hydrogen or loss of electron is called the oxidation. Just addition of oxygen or a removal of hydrogen, a loss of electrons, addition of oxygen, a removal of hydrogen, loss of electron. Just one sentence, that is the definition of oxidation. So the oxygen comes from where? Especially the reagents are sulfuric acid, monohydrate sulfuric acid, potassium dichromate, chromate, potassium permanganate, osmium tetroxide, hydrogen peroxide, PCC. So, etc. Many reagents are there nowadays. So, all these reagents act as oxidizing agents. They are providing the oxygen atom to the compound and that compound converted to the another compound. So what type of compounds are oxidized and what type of compounds are formed? Just alcohols oxidized, example, alcohols oxidized to carbonyl compounds. And further carbonyl oxidizes into the acids. So, what type of alcohols? Primary alcohols, example, this is the primary alcohol oxidized to aldehyde or CHO. This is the aldehyde. And it further oxidized to form the acids or COH acids. Secondary alcohols oxidized to ketones. Whereas tertiary alcohols what type of compound is formed? The primary alcohol gives aldehyde and secondary alcohol gives ketones and tertiary alcohol gives what? Is give any compound or no? No. There is no reaction takes place on oxidation of tertiary alcohols. So let's look the two reagents, especially our syllabus, according to our university syllabus, the chromate and permanganate. The oxidation of alcohols with chromate and potassium permanganate. So they will ask directly oxidation reaction with the chromate, or sometimes they ask the oxidation reaction of alcohol, oxidation with alcohol with potassium permanganate, or sometimes generally they will ask you can write any other one, either potassium chromate, potassium permanganate or chromate. So general reaction is one, general reaction is compulsory, and its mechanism. You must write that 5 marks question. Okay? So now, oxidation with chromate. Oxidation with chromate. General reaction and mechanism. First of all, write the general reaction. Secondary alcohols oxidized by chromate to form the ketones. This is the general reaction and mechanism. In mechanism, 2 steps are there. The first one is the formation of chromate ester. The first step is the formation of chromate ester. So in this, secondary alcohols react with chromate. The chromate is having the +6 oxidation. The bond comes, this bond, the chromate oxygen to chromate double bond, one bond converted into this side, it becomes the negative charge, and the chromate gets the positive charge, and electrons of oxygen transferred to chromate. And to form this type of compound. And here this hydrogen, when the proton transfer to oxygen atom, transfer of hydrogen or proton, transfer of proton, simply write the transfer of photon. So what type of compound is formed now? Chromate ester. First of all, this compound is formed, positive and negative, it is a salt, and transfer of proton to oxygen atom and form the ester compound. What ester? Chromate ester. This is the first step. And in second step, the chromate ester react with water in hydrolyzed, and the water molecule obstruct the proton to form the H3O plus, and the bond comes to the side, and slowly the electrons to come to this side. To form the acetone molecule. Now R is equal to, you have to take methyl or ethyl or benzene, what if, etc. Ethyl C2H5 or ethyl or any alkyl group chain. So acetone, and what about the chromate? This plus CRO H and double bond O. And the chromate react with hydronium ion. React with hydronium ion. Mean the bond comes to this side and it gets a negative charge, and one hydrogen atoms transferred into the oxygen to form the Cr OH minus and OH and plus water. So this is the plus for oxidation. The oxidation number from plus 6 to plus 4. So first of all, the mechanism of oxidation, first formation of the chromate ester, then chromate ester 2 and hydrolyzed to form the acetone molecule. So R is the alkyl group, methyl, ethyl, propyl, butyl, aryl group also some, vinyl, allyl. So whatever the compounds are, just remember, either you can write like this or methyl, no problem. This is the chromate, CrO3, using chromate. And now, please take down. Now, oxidation with KMnO4, potassium permanganate. So first, KMnO4 a solvent, potassium plus manganate. Manganate ions formation takes place. So when the secondary alcohols react with the base, when the base obstruct the proton to form this type of ion, then react with manganate bond comes to this side, it gets the positive charge and it gets the negative charge, positive charge, and the bond formation between oxygen and metal, the manganate metal, and manganese metal, to form this type of ether-like compound is formed here. ether-like, not ester-like. Here, now, the oxygen minus obstruct this proton or simply the proton transfer. Then the bond comes to this side and the electrons are come to this side. And to form the ketone compound, and it become the MnOH and double bond O. So or we can say HMnO4. So this is the mechanism of the oxidation alcohols with KMnO4. The simple mechanism. First, KMnO4 forms the ions potassium plus manganate. Then first react with OH to form the ion, negative ion, or alkoxide ions, we can say alkoxide. And the bond formation between the metal and oxygen. Then after that, the proton obstructed by the O minus and the bond come to this side and electrons to transfer into manganese and to form the ketone. This is the mechanism with the chromate ester as well as the KMnO4. Chromate as well as potassium permanganate. Okay, thank you very much.